Hello everyone, welcome back. Today we will be entering chapter 6, which is on circular motion. So there's two subtopics in this chapter, and the first one is on uniform circular motion. So in this subtopic you have to be able to describe what is uniform circular motion and convert the units between degrees, radian, and revolution or rotation. Okay, so what is actually a uniform circular motion? Well, when a particle or when an object moves in a circle with constant speed, the motion is known as uniform circular motion lah. For example, if we are going through a roundabout, we are actually doing a uniform circular motion lah, macam di figure here. And then another example is when a satellite is moving in a circular orbit, and lastly an ice skater which is skating in a circle. Right, so the acceleration is always directed towards the center of the circle. So this acceleration here, which is pointing towards the center of this circle, is known as centripetal acceleration. Okay, so that's one thing that you need to know. And you also have to know what is period, where period is the time taken for one complete revolution, or also known as cycle or rotation, in which the unit is second. And then lastly, frequency, which is defined as the number of revolutions completed in 1 second. Okay, completed in 1 second. The unit is either hertz, or you can also write per second. And the way you calculate it is using this formula here. So it is just 1 over the period. Okay, so this is a derivation in order to get the formula for angular velocity. So angular velocity is basically just the rotational punya velocity. So for example, if we have circle here, the angular velocity is just this. So this is omega, known as angular velocity. The differences between angular velocity and tangential velocity is tangential velocity is something like this. It is always perpendicular to the centripetal acceleration, which is AC. Okay, right, so the formula for angular velocity is 2 pi f ataupun 2 pi over t. Okay, and then to convert the angular velocity into tangential velocity v here, we can just calculate it using this formula, where r is the radius of the path of the circular path. Right, okay, and then the unit for angular velocity is radian per second, in which pi radian is equal to 180 degree. Lepas tu 2 pi radian pula 360 degree lah. Okay, so you need to be able to convert the degree into radian lah, supaya dapat SI unit dia, which is radian per second. Okay, so centripetal acceleration. So this is basically just the derivation parts. You can read it on your own, but what you need to know is the formula for radial acceleration or centripetal acceleration is v square over r. Okay, so r pun sama juga, it is the radius of the circular path. Okay, so based on this diagram, we know that acceleration will have a constant magnitude, so all of this will have the same value. However, the only thing that is changing is the direction lah. Okay, so if you were to draw a diagram, you have to remember that the tangential velocity is always perpendicular to this centripetal acceleration. Okay, so they are always perpendicular to each other. Right, I think that's it for subtopic, the theory in subtopic 6.1.